All right, well, let's continue some discussion of some of the properties of these inverse functions. We could say that we had two inverse functions, if f of x and g of x are inverse functions. What would happen if we took a composition? Well, what would happen is that the two functions would, in effect, undo one another. Inverse operations are operations that undo each other. For example, if you recall from our very beginning in algebra, we talked about some properties like the inverse multiplicative property, which said that if we took 1 over a number a and multiplied it by the number a, we would get 1. In other words, the multiplication of a times its reciprocal is equal to 1. That is called a multiplicative inverse. They undo each other. We also had an additive inverse. The additive inverse went like this. If we took a number a and we added its opposite, we would get 0. These are operations that undo one another. So if two functions are inverse functions, they should undo each other as well. And we say by composition, f of g of x equals x, and g of f of x would also equal x. So for example, let's verify that f and g in our first example are inverses by using the composition. So we'll check f of g of x, and let's see what happens. When we take the composition f of g of x, it means that everywhere we see x inside the function f of x, we replace it with the expression that we find for function g of x. So we're going to take 2/3 of the function 3/2 x minus 6, and then add 4 to that, and see what happens. Well, distributing 2/3 times 3/2 gives us 1x, minus 2/3 times 6, which is 4, plus 4, we end up with x. Now, we should test it the other way around as well, just to be certain. So we're going to check g of f of x in this particular example, and do the same idea. Everywhere we see x in the function g of x, we're going to replace it with the expression we find in the function f of x. So that is 3/2 times the quantity 2/3 x plus 4 minus 6. We'll distribute the 3/2. 3/2 times 2/3 is 1x, plus 3/2 times 4 means divide 4 by 2 and multiply by 3. That's plus 6 minus 6. So, in fact, f and g of x are inverses of one another. When it is the case that these two functions are inverses, we often use this notation as well. We could say that the composition f of f inverse of x is the same as the composition f inverse of f of x. And either way that we do it, we should undo one another and get x. So that notation right there, very important to recognize. Let's try it again. Let's do another example. This time, let's take our functions f of x equals 1 plus the cube root of x, and g of x equals x minus 1 cubed. Are these inverses? Well, to check it out, let's try our composition f of g of x and see what happens. So making my substitution into f of x, I'm going to have 1 plus the cube root of, instead of x, g of x, which is the quantity x minus 1 cubed. Well, the cube and the cube root, those two things undo each other. And so we end up with 1 plus cube root of quantity x minus 1. And of course, those ones cancel out. By subtraction, we're left with f of g of x is equal to x. Other way around? Sure, should work, right? G of f of x. Making the substitution, we're going to replace x with the quantity 1 plus the cube root of x minus 1 quantity cubed. When we simplify by subtracting our common terms, we're going to get cube root of x quantity cubed, And since these are reciprocal operations of one another, the cube and the cube root undo each other, leave us with just x. And so, yes, we could say that f inverse of x in this second case is actually the function x minus 1 cubed. All right. Well, how are we going to use this? In our next video, we'll go about actually finding the reciprocal functions, finding the inverse functions. Not reciprocal, it's very different. Stand by.